and I want to paste. And when they say use an image, I think they mean this. Let's undo. Okay. So now, here's cosine, and then let's add on. So then when we talk about inverse cosine, this is our range, this is our domain. All right. So now, notice we have inverse cosine first, so that number needs to be between -1 to 1. I think root 2 by 2 is indeed between -1 to 1, so we're in the clear. Okay, so let's look at the first one. Now we have inverse cosine of a -√2 by 2. Okay, this is going to be equal to some angle. Okay, so then what this is saying is that cosine of what angle equals a -√2 by 2. So now, cosine is either quadrant 1 or 2, right? Cosine is going to be negative in quadrant 2, so my claim is that we should be discussing things in quadrant 2. Now, cosine of what gives us a -√2 by 2? That's going to be 45 degrees away from the x-axis in quadrant 2. So that means we're going to say 180 degrees minus 45 degrees. That gives us the 135 degrees. So theta is 135 degrees. So now theta equals 135 degrees. Okay. But then now they're asking us to find sine of theta, right? So then we're just going to do sine of 135 degrees. Really, this is just sine of 45 degrees in quadrant 2. So sine of 45 is √2 by 2. In quadrant 2, sine is our x and y. Sine. Let's see, cosine, sine. So that's our y in quadrant 2 should be positive. So we should be doing √2 by 2 should be our result. Positive √2 by 2. I think this is it. I'm going to just put this original in the calculator. I think that'll be safe to do. That's about the best I can do. Just check it. If you find any error, especially like if you're my student or anybody, I don't really care. If you find an error, just let me know and we'll correct it or do whatever we need to do. I don't think that matters, so I'm going to just leave it in whatever mode it's in. I'm going to do sine of the inverse cosine of a negative square root of 2 by 2. So it's going to give us an angle, and then sine of the angle, and it should be some positive irrational, and then we just check with the square root of 2. Square root of 2 divided by 2 should be the same thing. Okay? So again, because it's a video, just rewind it, watch it as many times as you need to until it sinks in. Let's do another one. Alright, it says use the sketch to find the exact value. Okay. So I think we did tan as well, so I'll pull that back up. Did we? Yeah, here it is. Tan. Yeah, this whole discussion. So it's the same discussion. So I'm just going to borrow this since we've done it already. I want to copy. Okay. And I want to paste. And I'll just move it all right here. Okay. So it says use a sketch. So now we're talking about inverse tan. Did I put theta? I sure did. I meant to put y here. Did I do that anywhere else? There should be a y as well. Because you take secant of angles and inverse secant of ratios or whatever. They're not angles when you're doing inverse secant. The answer is gonna output an angle, but you're not gonna take the inverse trig function of an angle. So that's why those need to be things other than angles. Okay, I think this is fine now. All right. So now, inverse tan Any rails? Okay. So now let's look at this. It says use a sketch. So our domain for inverse tan is all reals, so all reals will work. So now if we say inverse tan of a negative 2 by 7 equals some angle, what we're saying is that tan of some angle equals a negative 2 by 7. Right? Now tan is negative in quadrants 2 and 4 because it has a negative slope, but we restricted tan to quadrants 1 and 4. So that leads me to believe we should be talking about quadrant 4 because tan is positive in quadrant 1. So since we want it to be negative, we should be doing quadrant 4. Okay. So now, so tan of some angle is going to give us a negative 2 by 7. I don't think that we could pull that directly from the unit circle. One thing we could do, so tan of theta is what? Sine over cosine. So let's look at this. And I'll do this in another color. This is like background thinking. And we'll do this one. So then tan of theta is sine of theta by cosine theta. But then sine xy is our y over r. Cosine is x over r. So then that means that tan is going to be y over x. Okay, now we're in quadrant 4, and our y over x is negative 2 by 7. So we can also use the x squared plus y squared equals r squared. Okay, so let's kind of put this together. So our y is 2. Now if we're in quadrant 4, x is positive and y is negative, right? So that means we're going to have 7 squared plus negative 2 squared equals r squared, so we can find that r. That's 49 plus 4 equals r squared. So then r equals the square root 53. Okay. So tan of theta should be y over x. We have that. Okay, so now we have our x, y, and the r. So then now let's go back and find. So now we should be able to find cosine of theta. But cosine of theta is x over r. Okay? So our x we've already deemed was 7. And our r is root 53. So then our cosine of whatever angle that is going to be 7 root 53 over 53. Now if we're in quadrant 4, cosine being our x should be positive. So this should be positive. Let's see if we don't have the result. So what I'm going to do is just put the original in the calculator and see if I get the same result. So I'm going to copy. I'm going to paste the answer here. Shrink it down. So now let's put this original in and see if we get this answer. This is how we can check something like this. It's clear? Okay, now that's the angle, then we take. So right now it doesn't matter if we're in what radians or degrees. So I'm going to leave it, and we should get the same thing. Now let's see. We got cosine of inverse tan of negative 2 by 7. And we should get some positive rational irrational number. Okay? So then we just put in our answer and see if it's the same. 7 times the square root of 53 divided by 53. By the good grace, it is the same. That's a lot of work to get that wrong. But see, the thing is, it's like when you do all that work and you get it wrong, that does one of two things. Either it discourages you and keeps you trapped, or you'll be like, okay, you know what? I've come this far. I didn't come this far to waste all that energy. So after spending so much time and getting it wrong, then you're like, okay, I got to get this right. I done wasted this time. I got to keep going until I get it right. Otherwise, the whole time will be a waste. So after going for a long time and you get it wrong, then that should light a fire under you. And you're like, look, I didn't spend all that time to get this wrong. So you should like activate and keep pressing until you figure it out. That's how it goes for me. Anyway, I think we have like a couple more, and then we'll wrap up. Oh, one more. So this is the last one for this session, and then we'll wrap up. All right. So then this one comes and asks us to multiply and simplify. So let's take a look at it. So now we have tan of x minus 1 quantity squared, but that means we have tan of x minus 1 times tan of x minus 1. That's what the squared means. So then if this is the case, we just FOIL, okay? So if we FOIL, we'll get tan squared x minus tan x plus 1, okay? So now it looks like we have some trig identity coming into play. So now I don't really know the trig identities. The only one I know is sine squared x plus cosine squared x equals 1. That's all I know. Now if I want tan, I'm going to divide the left and right by cosine squared. Cosine squared x, cosine squared x, cosine squared x. This is just something, I don't even think anybody told me this. I just noticed that the original was similar to the other trigonometric Pythagorean identities, and so this is just something that I kind of made up on my own. But I think it's okay. I think I've seen it other places as well. But you kind of have to develop little things like that for a lot of these things. So sine over cosine is going to be tan squared x. Now we have our tan. Cosine divided by itself is plus 1. And the reciprocal of cosine is secant squared x. Okay? So then, now, we got our tan squared and we got our 1. So that's really just secant squared. So then, what ours ends up being, tan squared plus 1 is secant squared. So we have secant squared x minus 2 tan x. So this should be secant squared minus 2 tan x, which is b. Okay, so that confirms the result that we have above. Okay, so that kind of concludes that session. Just take a look at it, do the best you can. I'm here for questions. You can email me with questions, and I can make more videos. I'll make them till I'm blue in the face, just because it's so much fun. So from one beautiful mind to another, happy studying and enjoy the rest of your evening.